x is equal x squared minus 4x plus 10, and c is a positive integer less than 5, what is one possible value of f
of
c?
c? Yeah. So it's a function, f of x equals this thing, and we have to calculate f of something. So f of x is simply the fancy way of writing y. It's nothing different. It's just y. Y equals this thing. So what will be the value of y when x is something? That is, what they are dealing with. So if I'm writing f of x equals x squared minus 4x plus 10, and I want to know what is f of 1, what should I do?
You should.
Yep. X is here, Y is here. I'll be making the table. F of x equals x squared minus 4x plus 10. I want to know what is f of 1. F of 1 means what is the value of y when x is 1. So you'll be plugging in the value of x as 1 everywhere. Okay. 1 square minus 4 times 1 plus 10. How much will that be?
In total?
Yeah, 1 square minus 4 plus 10. 1 minus 4 plus 10.
13.
I think it's 7 because 1 minus 4 will be negative
Negative 3.
3, and then plus 10, it'll be positive 7, right?
Yes.
So when x is 1, y is 7. Got it?
Yes.
Okay. Now can you tell me what is f of 2?
Would it just be multiplied? So the 4, it would all be 2. You plug in the x, and the x is 2.
Yes, you'll be plugging x as 2. So it'll be like 4 minus 8 plus 10. So it'll
Should
be
be,
how much?
I think, would be negative 4, but yes, 6.
6. So when x is 2, y is 6. Fine. Now let's see the question what they are talking about. They are saying that, and c is a positive integer less than 5. What is the one possible value of f of c? Okay, so they just want us to plug in the value of c as, or x as any number which is less than 5. We have already done that, I think, right? We have plugged in 1, we have plugged in 2. We can plug in anything, 4 maybe. We can plug in 3 also. So we have to check out what is one possible value of the y. That can be 7, that can be 6, or else you can go for 3. What is f of 3?
Minus 2. Negative 3. It would be 7.
19 minus 2, yeah, that's 7, correct. So when x is 3, y is 7. So we can have, multiple answers in this, because we can plug in any value of c which is less than 5. We can plug in 4, we can plug in 3, we can plug in 2, we can plug in 1. But it's a positive number, so we can plug in 4, 3, 2, 1. We have plugged in already 1, 2, 3, and we can even plug in 4. We'll be getting all the answers, 7, 6, maybe we'll be getting 6 again, whatever. So you have to plug in one of the answers. What is one possible value of f of c? F of c means simply y. What is one possible value of y? Can you tell me? What is that?
The 1 plus 1 value of y.
What is one possible value of y?
Would it be the ones that are on the y side? So 7.
Yes. Yeah, 7 or 6, whatever you like.
You could
You
pick
can
either one.
either
It'd
of the
still
one.
be
Yes.
correct.
Yes, both will be correct. Either you take this or this, they both will be correct. Okay, so we're having multiple answers sometimes. That doesn't mean that we're wrong. We can plug in any one of the answers, and that is correct. Question number 17, I can show it here. Question number 17 in the answers. So math test. See here, 6, 7, 10. We can have many answers. So you can plug in any one of them. Okay, so you can do anything here. Let's go for 18. We're having a big question here. What I do is I break it, understand it, move on to the next point. That's what you will do here. Try to break it. You'll not read the complete question. You'll read 1 or 2 lines, understand those 2 lines, move on to the next 2 lines, and then so on. Start.
Students in a science lab are working in groups to build both a small and a large electrical circuit. A large circuit uses 4 resistors and 2 capacitors, and a
So
small circuit uses 3 resistors.
yeah, we'll be trying to, get the information from that. We're having 2 types of things here. They are creating the larger circuit, maybe something like that, bigger one, and one smaller circuit. And circuits are made of resistors and capacitors. So one large circuit consists of 4 resistors and
2 capacitors.
2 capacitors, and one small circuit consists of how many?
3 resistors and 1 capacitor.
Okay. For example, if I'm having 2 large circuits, how many resistors will I require?
You would need 8 resistors and 4 capacitors.
Exactly. So it depends on number of circuits which I'll be using. I'll be requiring, those many resistors and those many capacitors. All right. So these are the 2 things which we have, understood till here. Now let's move on to the next one.
There are 100 resistors and 70 capacitors available. And each group must have enough resistors and capacitors to make 1 large and 1 small circuit. What is the maximum number of groups that could work on this lab project?
So one group is making at least how many large circuits and small circuits?
They're building at least with 1 group. At least 1, right?
At least 1, yeah. Each group must have enough resistors and capacitors to make 1 large and 1 small circuit. So they're telling you each group has to make at least 1 large circuit and 1 small circuit. Each group has to make at least 1 large circuit and 1 small circuit. But we're having a total of only 100 resistors and 70 capacitors. So if we are having only 100 resistors, how many large circuits we can make?
You can make out of 100, or is that split between the 2?
Let's yeah, we have to understand. Okay, one large circuit is taking 4 resistors and 2 capacitors, and one small circuit is taking 3 resistors and 1 capacitor. So how many will be total resistors and capacitors for making 1 large and 1 small?
It would be 4 resistors, 2 capacitors.
4 resistors and 3 resistors. In total, how much you need for creating 1 large and 1 small?
Would just combine them, so it would be 7.
So if I'm in a group, if I want to create 1 large circuit and 1 small circuit, I need a total of 7 resistors and
3 capacitors.
3 capacitors. So this is my target here. I need 7 resistors and 3 capacitors, but I'm having a total of 100 resistors and 70 capacitors. So if I'm having 100 resistors, how many can I, how many large and small circuits can I make if each large and small takes 7 resistors?
You can make 14
Maybe 7 times 14 is how much?
98.
Oh, okay. 7 times 4 is 28. 7 times 1, 7, 8, 9. Yeah, you're right. So you can make 14 large. Okay, so if I'm taking 14, 7 times 14, how much is 3 times 14? Is that
52.
below 70? Yes, it is below 70. So it's okay. So how many groups can you have? A maximum of?
14.
That's the answer. Are you following what happened here? Yeah.
Yes.
So that is, sometimes this question becomes more complex, like when you read the complete question in one go, and then we had to like think what's going on. That's why I try to break it in few parts and try to understand it and see the whole scenario. Okay, but I want you to, try these questions again yourself after like the session, maybe before our next session. Whatever the questions we are doing here, try to do them yourself so that we can see whether you're able to remember what steps we take and what strategies we applied. And if you are not clear, then you'll be marking that question again, and we'll be doing that again, because we need the steps, we need the strategies, we need the solution, method of solution, so that we can apply that again and again. Let's go to 19. We're having 1 minute left in this meeting. In our next meeting, should I send it to the WhatsApp or you?
Yes. So that way I can go on my laptop. That'll be
Fine,
perfect.
fine. Can you read this 19 first?
An angle with the measure of 7 pi over 6 radians has a measure of d degrees, where 0 is less than or equal to d that's less than 360. What is the value of d?
Any idea about radians, what that is?
No, I haven't.
Okay, very simple. Do you know how do we calculate the length? We can calculate it by feet, number of feet. We can calculate it by meters, right?
Yes.
We can calculate it by centimeters, even millimeters, and so on, inches. So we're having different ways of measuring the length of something. In the same way, we can have different ways of measuring the weight of like not the weight actually, the liters, milliliters, and so on, like the volume of something. In the same way, we can have different ways of measuring an angle of something. For example, you're having this angle as 30 degrees. And we know that when you go like this, it'll be 90. When you go the complete line, it'll be 180. When you go to the complete circle, roundabout, then it'll be 360 degrees. In the same way, we can we can write the degrees, we can write the angle in radians also. Radians